Today, I'll be showing you how to build a scalable web scraping API for large-scale data collection. Now, this API will use FastAPI and Python, and of course, I'll show you all of the deployment steps and how we can make it take advantage of multiple CPU cores. Now, this is great because a lot of companies need to scrape a ton of data, and when you want to do that in production, or you want to be using it a lot at least, you want to set up some kind of authentication, you want to wrap an API around it, and you want to make it easier to use than having to run scripts manually on your own computer. So this video will show you exactly how to do that. It will give you the architecture, the setup, and all of the code, and at the end of the video, we'll be deploying this out on our own virtual private server. So I'll walk you through all of those steps, and specifically in this video, we'll take advantage of the great instances provided by Akamai. With that in mind, let me quickly give a bit of information about myself. My name is Tim. I'm a developer advocate for Akamai and have been for the past 4 years, and I run a YouTube channel with hundreds of other programming tutorials. I love teaching and building projects out like this, and I'm excited to get started, so let's dive in. Now, as a reminder, we're going to be building a scalable web scraper. Now, we can build this really in any way that we want, but for this video, as I mentioned, we're going to be using Python and FastAPI. Now, we've chosen FastAPI because this is an asynchronous framework and it allows us to scale significantly better than things like Flask. In fact, using FastAPI will give us significantly better performance, and you'll see how we can tie that in with a bit of multi-processing to handle multiple requests at the same time and kind of overcome some of the limitations that you typically get when you use something like Python. However, before we get into all of the coding and building out the API, we're just going to set up our server. So we're going to set up the server, we're going to get it ready to actually handle our deployment, then we're going to write all of our Python code, build out the API, and then I'll show you how we host it on the server and then use it from any client that we want with some authorization. So what we're going to do is go to the Akamai Cloud Manager. I'll leave a link to that in the description. And if you don't already have an account, then you can sign up for free and get $100 free credit, which will be more than enough to get started with this project. Now, I already have an account because I use Akamai for pretty much everything. So let me sign into that, get to the Cloud Manager, and then we'll talk about setting up our instance. So I'm here in the Akamai Cloud Manager, and what we're going to do is start by creating a new Linode. You can see I already have a bunch of them listed here. So I'm going to go to create Linode, and this is going to be a new server that we can access to host our API. Now we're going to choose Debian 11 as our distribution. You can change this if you want, but Debian is probably the best for us. And then we're going to choose the region, which will be closest to most of our users. Now, in my case, I'm currently in the Middle East, so I'm just going to go with the India region here because that's closest to me. I'm in Dubai, and then we're going to go with the plan. Now, Linode does have plans as low as just $5 per month, but in our instance, we want to make this scalable and have multiple CPU cores so we can distribute the tasks out on those. So what I'm going to do is go with a dedicated here, and I want to make sure I have at least 2 CPUs. You can see we can start with the dedicated 4 GB, or we can go all the way up to 256 GB where we have 56 CPU cores if we really needed this to handle a lot of traffic. Now, theoretically, if you needed even more than that, you could create clusters of multiple Linodes, and you could have load balancers set up, for example, but that's a little bit complex. So for this video, at least, we're simply going to set up a single instance. And if you needed it to handle a lot more traffic, then you can go up to the highest possible instance that they have here. Now, the way that we write the code here, it will be distributable across multiple instances, but for our case, we're just going to use one. So I'm going to go with the 4 GB just because that's all I really need for testing. Again, choose the one that's going to be best for your use case, depending on the amount of volume that you're going to have, the amount of requests coming to your API. Okay, so we're going to go with the 4 GB here, and then I'm going to give this a name. I'm going to call this my web scraper. Then we need to enter a root password. So I'm going to type in my root password here. Obviously, make sure you don't share this with anyone. And then we're going to create this instance. So if we scroll all the way down here, we have some other options like firewalls, VLAN, user data, backups, all this stuff. We're just going to leave all of those at default and press on create Linode. Okay, so the Linode is going to spin up. It'll take a minute or two to provision. And what we're going to be looking for is this IP address because now we're going to SSH into it and start configuring it. So our Linode is now running, and the next step is to copy the IP address and go to a command prompt or a terminal, depending on your operating system, and SSH into the Linode so we can start configuring it for deploying our application. So I'm just going to open up CMD here, but you can open up PowerShell, you can open up Terminal if you're on Mac or Linux, doesn't really matter. Let me zoom in here so you guys can read this. And we're going to use the SSH command, which will be the same no matter what operating system you're on. So I'm going to go with SSH, and then we're going to do root at, and then we're going to copy the IP address of our server. Now this is going to allow us to log in as the root user, and what we'll need to do here is type in the root password. So first I'm just going to type yes here, and then we are going to type in the password that we set up when we provisioned this Linode. Okay, so that's going to give me access to the server here, assuming that I type it correctly. And the first thing that we need to do is actually disable root access. So whenever you're deploying something that is going to be a production application, typically you want to disable root access on the server. Now, this is as a security measure. It's typically better to create your own user and sign in as that rather than giving someone access to the root user where that could potentially do a lot of damage to your system. So in order to create a new user, we're going to do the following. We're going to type add user and then give this a name. And because I'm going to be building a FastAPI API, I'm going to name this FastAPI, but you can name it anything that you want, but I would recommend keeping it the same because a lot of the instructions will reference this name. So we're going to add user FastAPI, and we need to give this a password. Now you should ideally give this a different password than the root password, but it doesn't really matter. Just give it a password that you're going to remember. Make sure you type it in correctly twice. And then I'm going to go try again because apparently I didn't type it in correctly. Okay, so let's do this one more time. Okay, and there we go. Now for all of these fields, you can just leave them empty and then you can just type yes. And now you have a new user created. Now that we have the new user created, what we want to do is add this user to the sudo group so that it has super user permissions and it can do everything that we need it to do. So to do that, we're going to say user mod. And then this is going to be -a capital G and then sudo and then FastAPI. This pretty much just means we're adding the FastAPI user to the sudo group so that it's able to perform pretty much any command that we'll need. Okay, so we've added it to that group. And the next step is to disable the root access. So at this point, we now have a user that we should be able to sign in as. I already know this works because I've tested these commands, but you can log out and try to sign back in as the FastAPI user if you want. But for now, what we're going to do is disable the root access. So to do that, we're going to type sudo nano /etc/sshd/sshd_config. Now, at any point in time, if you're getting confused here, I will have a link in the description that has all of the instructions and all of the commands that I'm typing so that you can simply copy them in case you're not able to follow along with the video. So again, there'll be a GitHub link and there'll be a file in there that says Linux instructions, and that'll contain all of the stuff that I'm typing. So I'm going to go ahead and press enter here, and we're going to get into this text file. Now, what we're going to do is scroll down until we see this line here, which says permit root access. Now we're simply going to change this to say no, and then we're going to save the file. So I'm going to hit Control S, that's going to save the file, and then I'm going to hit Control X. You can see the commands at the bottom of the screen, and that's going to exit it for me. Okay, so now that I've done that, what I'm going to do is restart the SSH, process, so that when we sign in again, that change will be applied. So to do that, I'm going to type sudo systemctl restart and then SSH. This will again restart that process so that when we try to SSH in again, we're not able to use root. Okay, so let's hit enter here. That's restarted that for us. And the last thing we'll do before we try to sign in as our FastAPI user is we'll just update the system, which is typically good practice. So we're going to say sudo apt update, and we're going to wait for that to run. And then once that finishes, we're actually going to upgrade the system. Okay, so now that that command is done, we're going to type sudo apt upgrade-y to apply any of these changes. And this will take a second. And now we are finished. Okay. So now we want to try signing in as our new user. So we're going to clear the screen here and we're going to type exit. When we do that, that's going to bring us out of the SSH session. So now we're back to our main computer or our local computer. And what we're going to do is do the same command that we did before, except this time, rather than signing in as root, we're going to sign in as FastAPI. Okay, so this should work and we should be able to just type in the password that we set up before. And that should sign us in. And now you can see that we have FastAPI at, it's saying localhost, but really this is the server IP address. Okay, amazing. So now that we're inside of here, we're going to install a few packages that we need, and then we're going to start writing some code. We won't do it directly on the system here, although we could. We'll just write it on our own system and then move it over. So I'm going to type sudo apt install, and we're going to install the various Python packages that we need, just so that we're kind of ready to go when we do have our Python code written. So we're going to install Python 3, Python 3-pip, and then Python 3-venv. This is for creating a virtual environment, which we'll do later on. So let's hit enter here, and we need to type in our password. So let's go ahead and do that. We're going to hit Y for adding all of this additional space, or all of these additional things to the hard drive, or SSD, whatever it ends up being, and we'll wait for that to finish. All right, so that operation finished. So what we're going to do now is we're going to go into Visual Studio Code, or whatever code editor you want to use, but make sure this is on your local system, so whatever you're following along with the tutorial on, and we're going to start writing our API code. Now, the idea here is that we're going to write the API on our local system. We'll quickly test it to make sure that it's working, and then we'll put it over to the Linode, or to the remote instance. So typically, that's kind of what you do. You develop on your own machine, and then you move it over to the deployable or production environment. So let's start writing some code here. What I've done is I've opened up a new folder, and obviously I'm going to be writing some Python code. So in order for this to work, you should have some familiarity with Python, and you should already have Python installed on your machine. Now, the first thing we're going to do is create a requirements.txt file, because whatever we do here, we want to make sure that we can replicate this on the remote server, so the Linode, so all of our dependencies and all of that, we want to start keeping track of them. So inside of our requirements.txt, we're going to list the different Python packages that we need. So we're going to have FastAPI. We're going to have Uvicorn, which is actually going to run the server for FastAPI. We're going to have SQL and then Alchemy, and we're going to have requests and then beautiful soup 4. Now this is going to do the web scraping for us, and we'll talk more about the actual web scraping operations when we get to that point. Okay, so we have FastAPI, Uvicorn, SQL Alchemy, requests, beautiful soup 4. We could install those right now if we want, but I'm actually just going to write a majority of the code because we can't really even test this until we get it in the production environment. So we don't need to be testing it every step of the way. Okay, so now what I'm going to do is make some files. I'm going to have a main.py file. I'm going to have a models.py file to kind of handle our database. And then I'm going to have a scrape.py file. Now this is going to handle the web scraping operations. Okay, we're going to actually start inside of models and kind of define the data models that we're going to need for this project, because I find that's kind of useful when we're writing the API. We already know what to think about. Okay, so we're going to start by importing OS, which is the operating system. We're then going to say from SQL Alchemy, import, and we're going to import create engine, column, integer, string, and text. Okay, we're then going to say from SQL Alchemy.orm, we're going to import the declarative base and the session maker. And then we're going to go down here and we're going to say base is equal to declarative base. Okay, so what we're about to do here is define kind of a data model, or what the data is going to look like inside of our database. And for this project, we're going to use a SQLite 3 database, which just is hosted locally on the same computer. But if you wanted to, you could very easily change this to something like a Postgres database. And in fact, if you did want to use something like a Postgres database, which is a little bit more robust, you could easily do that using Akamai. They have a bunch of database options. I just want to keep this flexible so you guys can choose any database that you want. You could even use something like Mongo if you want to do that. Okay, so next we're going to say class, and we're going to say scrape job. Now, the idea here is with our API, we're going to be kind of accepting different web scraping jobs. So what will happen is there's going to be a request sent to our API, and that request is going to contain a URL and maybe some other instructions on what kind of data we want to scrape from a particular website. Now, what we're going to do is store that inside of a scrape job, and we're going to start initiating that job. Now, because web scraping can be a pretty CPU intensive operation, it might not happen right away. It might take 20 seconds, 30 seconds. It might take a certain amount of time before we actually are able to scrape the site. So we're going to have kind of two endpoints, one endpoint or one URL route for kind of starting the scraping job. And then we're going to have another one, which will check the status of the job so we can pull that endpoint, which just means continually send requests to it until eventually the web scraping job is finished. We'll talk more about this architecture later, but this is how we set it up so it's scalable so that we can send maybe multiple requests at the same time, start a bunch of different jobs, and then just get the result when they're finished rather than hanging and waiting for the job to finish, which could take an indefinite amount of time. We just don't know how long it's going to take. So scrape job here is going to handle kind of taking care of storing the results of our scraping operations. So we're going to say class scrape job. This is going to inherit from the declarative base here. And then what we're going to do is define all of the different fields that we want to have in this row. So we're going to say table name underscore underscore is equal to scrape underscore jobs. This is going to define the database table where we're storing this. We're then going to have ID is equal to a column. And this is going to be an integer column, and it's going to be a primary key. So we're going to say primary key is equal to true. And we're going to say auto, if I could get out of this, auto increment is equal to true, which means we don't need to manually assign the ID. It will automatically be incremented to be the next available integer. Okay, we're then going to say URL is equal to a column. This is going to be a string column. We're going to store the URL of the website that we're scraping. We're then going to say nullable, not name, nullable is equal to false. I'm sorry for the autocomplete here, which pretty much just means it can't be null. We need to pass a value for that. We're then going to say status is equal to column. This is going to be a string, and we're going to say the default is equal to pending, so that when we don't have a status when we first create this, it will just default to pending. Okay, we're then going to say result is equal to column and then text. And this is simply going to be all of the text from the web page that we scraped, or whatever the result is that we're trying to get. Okay, so now we have the table, and the next thing we need to do is figure out what file we're going to be storing our database inside of. So we're going to say db underscore file is equal to, and then this is going to be os.path.join, and we're going to join the os.cwd, so get cwd, which stands for get the current working directory. And then we're going to say scrape underscore jobs.db. So what we're doing is we're taking wherever this file is currently located, so this models.py file, and we're just combining that with scrapejobs.db, which is the name of the database that I want to store all of this information inside of. Again, we're using a SQLite 3 database, which is simply a file that exists on our local computer in this local directory in this case, but we could connect to a remote database later on if we want to do that. Okay, next we're going to say os.makeDirs, and we're going to say os.path.dirname, and we're going to say db underscore file, and then we're going to say exists okay equals true. Now what this is going to do is create this file if it doesn't already exist, so that when we try to read it, we don't get an issue. Okay, so now that we've done that, we are going to define our database engine. So we're going to say engine is equal to create engine. And for the engine, we are going to write the following. We're going to put an F string. We're going to put a set of quotation marks, and we're going to say SQLite, and then colon, and then 3 forward slashes. And then we're going to put the path to our database, which is the database file. This simply means load this file as a SQLite 3 database. Okay. Then we're going to say base dot metadata dot create underscore all, and then engine. Now we got to spell metadata correctly, but what this is going to do is look at this base class here. It's going to look at all of the classes that have derived from it, or our child classes, and it's going to automatically create these tables in our database for us if they don't already exist. So that's what this is doing. It's creating this table for us. Okay, after that, we're going to say session in all capitals, with capital for the first letter, is equal to session maker, and we're going to bind this to our database engine. Now, this is something that we'll be able to use in order to modify different rows inside of our database, and you'll see that in a minute. Then what we're going to do is just quickly test to make sure that this is working. So we're going to put a simple try, and we're going to say with session as session, we're going to do the following: session.query, and we're going to query the scrape job dot first, which just gives us the first entry from this result, just to make sure that works. And then we're going to say print database connected, just to make sure that that's working. And then we're going to say except exception as E, and then we're going to print error connecting, and we are going to render E. Okay. Now, the reason we're doing this is just so that we can see if there's an error connecting to our database. It will tell us what that error is, so that when we run our code, it's a little bit easier to debug. Now, ideally, this should just work, but obviously errors can happen. So that's why we're writing that kind of line down here inside of this models.py file. Okay, so now that we've got models.py, we're going to go into main.py and we're going to start creating the API using FastAPI. Now, if you haven't used FastAPI before, don't worry, it's pretty straightforward. So I'm going to start kind of defining the API. So we're going to say from FastAPI, and we're going to import with a capital fast and then in all capitals API. We're going to import depends. We're going to import the HTTP exception like that, and then the header. Okay, we're then going to say from models, and we're going to import the scrape job and the database session. Okay, then we're going to say from context lib import the async context manager, and we're also going to import multi-processing. Okay, so those are all of our imports for now. Now for our API, we want to have some kind of authentication. So ideally, we don't just want anyone to be able to call this API. They should have some kind of token or some kind of authorization in order to do this. Now, since this is a pretty simple project and we don't have maybe different users that are using the API, although we could set that up, what we're going to do is use a single token-based authentication. What that means is we're going to have a secret token that we store on the server, and only clients that have that token are going to be able to send requests to our API. So it's quite straightforward. It's really just like a password that they need to send to the API in order to use it. And I'm going to show you how we set that up with FastAPI. So we're going to start by defining the auth token. Now for the auth token, if we can spell the variable name correctly, which is proving to be difficult, we are going to just put anything that we want here. Now really you should just generate a random string, but for now I'm just going to go with my secret, and this can be API token 123, something like that. Okay. Again, this is not a secure token. You should make something that's a bit more random. I'm just doing something we can remember at least for later in the video. Okay, then I'm going to say pool is equal to none, and this is going to be a multi-processing pool, which is going to handle the different processes that are running asynchronously for kind of handling our web scraping operations. We'll get to that in a minute, but we're just going to define that variable. Okay, now we're going to create what's known as kind of a startup operation, something that we want to do when we first start up the API. So we're going to say and this is going to be the async context manager, and we're going to say async define, and then lifespan. Okay, and let's make sure define is spelled correctly. We're then going to say app is equal to, and this is going to be FastAPI, so sorry, colon and then FastAPI, and we're going to global this pool variable. Now what I'm going to do here is I'm going to initiate a multi-processing pool. A multi-processing pool is something that can automatically delegate tasks between different processes. So we can set up multiple processing in Python, and that allows us to run multiple tasks at the exact same time in parallel so that this API can handle as many CPU core operations as we have. What I mean by that is if we have 24 CPU cores, typically a standard Python application would only utilize one of those. But if we use multi-processing, we can actually delegate tasks to all of those different cores, and we can do that really efficiently and easy using this multi-processing library, which is built into Python. So we're going to create a pool. So we're going to say pool is equal to multi-processing.pool, and we're going to say the processes is equal to, and this is going to be multiprocessing.cpu_count. Now, I think I spelled processes incorrectly, so let's fix the name here. But what we're defining is how many different processes we want to have inside of this pool. Now, we want to have as many as we have CPU cores. So if we have 12 CPU cores, we want to have 12 unique processes. Now, what will happen as we add tasks into this pool, it will automatically handle delegating these tasks, kind of like a load balancer, to the different processes or CPU cores that we have, so that we can handle as many tasks as possible at the exact same time in parallel, fully utilizing the CPU, which is one of the main advantages of Akamai and this Linode instance. They have really fast, efficient CPUs. Okay, then we're going to yield. Okay, and then we are going to write pool.close and then pool.join. Now, this yield here is pretty much saying what should we do after or when we're shutting down this application. So the first part here is kind of what happens at startup, and then the ending part here is what happens at teardown, so when we're closing the app. Now the yield makes this function something known as a generator. You don't need to worry too much about that, but pretty much FastAPI can use this, and it can kind of use the yield to determine when we should do the startup operation and when we should do the teardown or shutdown operation. Okay, so now that we have that context manager, we're going to create our FastAPI app. So we're going to say app is equal to FastAPI, and we're going to say lifespan is equal to lifespan, the function that we just wrote, and that'll automatically use this function as I described. So now that we have our FastAPI app, we can start creating some different routes or endpoints that we can go to from our API. So we're going to first actually write a helper function here called verify token. Now remember, I mentioned that we're going to have some kind of authorization token. Well, that's what this function is going to use. So we're going to say x underscore auth underscore token. We're going to say that this is a string. Okay. And this is going to be equal to the following, which is header and then ... Okay, this is some advanced Python syntax, but the point is we're actually going to use header from FastAPI to strip out this specific variable or this specific key, which is the xauth token, which is a string. And then we're going to be able to use that inside of this function without having to do all kinds of advanced kind of parsing through the headers of a request. So we're going to say if the xauth token does not equal the auth token, then we're going to raise an HTTP exception. Now this is simply going to say status underscore code of 403, which is, I believe, unauthorized or forbidden, something like that. And then we're going to say invalid auth token. Okay, so the point is we're going to look at the header of the request. The header is going to contain things like the authorization token, and we're going to make sure that the authorization token passed is equal to what we have on the server. Now we could have multiple tokens if we want to do that, but in this case, we're just using a single token. And this token does not expire, but typically it's a good idea to have tokens that expire, and then you can renew a new token using login credentials and all of that. We're just keeping it really simple for this authorization, but obviously you can make this more advanced if you want. Now, if the authorization token either doesn't exist or is not equal to the auth token on the server, then we're going to raise an exception, which will mean that they're not able to actually follow through with the request that they sent. Okay, so now that we have verified token, we can write our different routes. Now there's two things we want to do. The first thing we want to do is allow the user to submit kind of a request to start web scraping a particular URL. And the second thing is to give the user the status of one of the jobs that they've started, because again, they don't know whether it's completed or it's still in progress. So we're going to start by saying at app.post, and this is going to be /submit. And then we're going to say the dependencies are equal to, and we're going to put a set of square brackets, and we're going to say this depends on verify token. Now we can actually put multiple dependencies here if we want, but what this means is that we're going to call this verify token function, the one that we've just written here, before we allow you to actually execute this route so that we know that you're authorized before we go into handling what I'm going to write in this function. So then I'm going to say define submit underscore scrape underscore job, and we're going to say URL is equal to a string. Now, what this means is that you're going to have to pass a question mark and then URL equals to, this is what's known as a query parameter, when you send this post request to this endpoint so that we know what URL it is that you want to scrape. You could handle multiple arguments here if you want, or query parameters, but in this case, we're just going to use the URL. So then what we're going to do is say session is equal to session. We're going to create a new instance of that session. And then we're going to say new job is equal to a scrape job. Now for the scrape job, we're going to say the URL is equal to the URL that the user passed. And we're going to say session.add, and we're going to add this new job. Then we can say session.commit, and this is how we create a new instance in our SQLite database. We created a database session. We created a new instance of what it is that we wanted to add. So we want to add a new row for scrape job. We added it to the session, and then as soon as commit is called, this actually applies it to the database and adds it in. Okay, perfect. Then we're going to do web scraping logic here, which we'll write in a minute, and we're going to return the following. We're going to say return. We can just return a normal Python dictionary, and this will automatically be converted to JSON for us. And we can say job underscore ID colon, and then this can be new job dot ID. And then we can pass the status. So we can say status is equal to submitted, just indicating that this worked properly. Okay, so we are creating the new row in our database, the new scrape job. When we do that, an ID is going to be created for us. So we can return that ID so the user knows what to use when it looks for the status. And then we have the status. We're just saying, okay, this was submitted. Obviously, we'll actually do the web scraping here, but we're going to leave that for last. Okay, next we're going to write another endpoint for getting the status of a job. So we're going to say at app.get this time. And this is going to be /status/ and then we're going to take in the job underscore ID. This is what's known as a path parameter, and you need to directly put this in the path of the URL. So rather than putting a query parameter like URL here, although we could do that, we're just using a path parameter because I wanted to show you something different. We're then going to copy this dependencies array here, or list, and just paste it in here because it will be the exact same for this. We're not going to let you get the status unless you have that auth token. We're then going to say define get underscore status, and we're going to take in the job underscore ID, which is an int. This time it will be taken from the path parameter because we've written the matching names here, not from a query parameter. Okay, then we're going to create a session. So we're going to say session is equal to session. This is kind of the process whenever you're interacting with the database, but this time we're going to query the database. So we're going to say job is equal to session dot query, and we're going to query the scrape job. And we're going to look for a .get of the job ID. So this is going to look in the scrape job table for any elements or rows that have this particular ID, which is the one we're looking for the status of. Now we're going to say if not job. So if no job exists with that ID, we're simply going to return an error. So we're going to say error and then job not found. Now this won't actually give us an error status code. It will give us like successful, but it will say that the job was not found. If we wanted to give an error status code, we could raise an HTTP exception of something like 404, not found. That's another option. In this case, I'm just going to return a normal kind of piece of JSON. Now, if that wasn't the case, that means we do have a job. So what we can do is return the information that we have about it. So we can say job underscore ID is job.id. We can then say the status is job.status, and then we can say the result is job.result. Okay, amazing. So let's save that. And now we have this main file. Let me zoom out a little bit so it's a bit easier to read. You can see that we have this async context manager. This is handling kind of the startup and teardown operations with our multi-processing pool. We have our authorization token verification, and we have the route for submitting and for getting the status. Now, in theory, this API currently works and we could test it, but obviously we're not actually doing any web scraping, which is the whole point of this project. So now we need to build the web scraping code. Now, for the web scraping code, I'm going to keep it nice and simple and allow you to change this and make it more flexible because I imagine you all have your own kind of process for web scraping, but I'll give you the basics. So we're going to go to scrape.py. And we're going to write a simple web scraper, which is just going to parse the HTML and look for the title of a web page. Now, of course, you could scrape anything that you want, and probably you want to scrape more complex data. You might want to do different things for different websites. But the point is, what I'm going to do here, you can change to anything that you want. I just want to get some information so that we have kind of a working prototype. So I'm going to go with import requests. I'm then going to say from Beautiful Soup 4, import Beautiful Soup. And I'm going to say from models, import the scrape job and the session, because we're going to need to store the result in our database. Okay, then we're going to create a function called scrape URL, and we're going to take in the job underscore ID and the URL that we want to scrape. Okay, so now we're going to create a session. So we're going to say session is equal to session. We're going to say job is equal to session dot query, and we're going to query the scrape job dot get. Let's make sure that this is typed correctly first. And we're going to get to the job ID. And then we're going to start setting the status. We're going to say job.status is equal to in underscore progress. This way we know that this has actually been picked up by one of our CPU cores and we're now working on it. So the status will allow the user to, maybe if they have a front end, display, okay, we've submitted it, now it's in progress, now it's finished, or maybe it was canceled or it failed or something along those lines. Okay, so we're going to say job.status is that, and then we're going to say session.commit to update the database so that when they pull that new endpoint that we wrote here, this status, they will get the updated status. Okay, then we're going to say for attempt, and this is going to be in range 3, And the reason we're going to set this up is that we'll perform a retry. Now with web scraping, sometimes maybe a website's down, maybe there's a weird error, weird stuff happens when you're using the web. So we're going to retry this 3 times just to make sure we give it a fair shot before we say that this job has failed. So for attempt in range 3, we're going to say try, and here we're going to put our web scraping logic. Now we're going to start by simply getting the HTML of the page. So we're going to say response equal to request.get, and then URL. Now there is potential to be blocked here, to be picked up as a bot. That can happen. If you want to get around that, there is all kinds of different tools and services you can use. I'm not going to promote any here, or mention ones that you can buy because a lot of them are paid services, but the point is you can look for those. And also you can use other modules like Selenium, Playwright, Puppeteer, which give you some more web automation control. So you can do things like interact with elements, render dynamic content. I'm just giving you a very kind of simple vanilla version of web scraping. There's all kinds of more advanced tutorials you can watch. So we're going to go request.get URL, and then we're going to check the status of this. So we're going to say if response.status_code is equal to 200, which is a successful status message, then we're going to parse the HTML. So we're going to say soup is equal to beautiful soup, which acts like an HTML parser. And we're going to say response.text, which will be the content of the web page. And we're going to say HTML.parser. Now this is going to give us kind of like a DOM-like structure that we're able to navigate through using the beautiful soup library. So there's all kinds of cool stuff you can do here, searching for particular tags, looking for different tables or elements. We're just going to look for the title of the site. So we're going to say title is equal to soup.title.string if soup.title exists. Otherwise, we're going to say no title. Okay, so we're just looking for the title, and then we are going to add that to the result. So we're going to say job.result is equal to the title. And if we want to be a bit fancier, we can do something like an F string here, and we can say title, and then we can put inside of here the title. Okay, then we can say job.status is equal to complete. And we can break. When we break, we're going to get out of this because now the attempt is finished. Okay, otherwise, we're going to say else job.status is going to be equal to failed. And we're going to say job.result is equal to an F string. And we're going to say failed with status code. And then this will be response.status code. Okay. Great, so that works. And then we're going to handle our exceptions. So we're going to say except, and this is going to be exception as E. And we're going to say job_result is equal to, and we're going to put an F string, and we're going to say error, colon, the string of E. And then we're going to put attempt, and this is going to be attempt plus 1. And then divided by 3, or kind of over 3. So we know we're on this attempt of 3. Okay, and then we're going to say finally, and we're going to go session.commit, and then session.close. And actually, quick fix, I'm going to go job.result, not job_result. And let's zoom out a little bit, and that should be our scrape URL function. Now we can give some better results, and we can make this better and change it and do some more advanced web scraping. But for now, this should retry up to 3 times, and it should be able to grab the title of the web page for us. Now, if it's not able to do that after 3 times, then we're going to have some kind of error message for the result, and the status should be equal to failed. All right, so that is it for this code. Now we need to import this from main. So we're going to go up here, and we're going to say from scrape import scrape URL. And now we're going to write our web scraping logic here, which is simply going to call that function and add it to our multi-processing pool. So we're going to say pool.apply_async, and we're going to take the scrape URL, and we're going to say the arguments are equal to, and this is going to be the new job.id and the new job.url. Now what this is going to do is it's going to add this function with these arguments, right? Because if we go look here, we have the job ID and the URL to this pool. Now it may immediately be picked up and start being handled by one of our CPU cores. However, if all of the CPU cores are busy, then the pool will automatically kind of associate it or attach it to the next process as soon as it's freed up and it's finished the other web scraping. So this way we can technically handle an infinite number of requests at once, and they'll just automatically kind of be handled and processed whenever we have time. So it might take, a few seconds or however long, depending on how many requests we have, before we start picking up these new jobs, but they'll automatically be added in the pool and that'll be handled for us. So we don't need to write this complex logic and set up our own queue and all that kind of stuff. The pool will just handle it for us. Okay, amazing. So that's pretty much it for our API. We have our main.py, models.py, scrape.py, and requirements.txt. Now we can test this locally if we want. So let's do that quickly just to make sure that this spins up. And then we're going to put it over in our production environment and start deploying it. So to do this, we're going to create a virtual environment. Now to do that, you can type Python -m venv and then venv. Now this means we're going to create a new virtual environment using venv. The virtual environment is called venv, but you can call it anything that you want. And if you're on Mac or Linux, you may need to change this to Python 3, but for Windows, for some reason, for me, that doesn't work. So I'm just going to go with Python. It's going to create this new virtual environment. I'll just press yes, so VS Code picks it up. And now we need to activate the virtual environment. Now to activate the virtual environment, if you're on Mac or Linux, is going to be source, and then it's going to be venv, which is the name of it, /bin, and then /activate. Now, this command will work on any operating system other than Windows, but on Windows, it's a little bit different. On Windows, it's going to be source venv scripts / and then activate like this .ps1. And I believe the activate is actually with a capital. Now, this is the PowerShell activation, and you can see I'm currently in PowerShell right here. If you're not inside of PowerShell, I believe there's an activate.sh or an activate.bat. You can actually go look at it if you want. You can go venv scripts, and you can see we have a PS1, a bat, and a deactivate. So depending on if you're using bash or normal CMD or PowerShell, you've got to change this. So I'm going to go activate.ps1. And then it should do this. However, that's giving me a problem because I have source. So sorry, it's actually just this with the activate. And then you'll see that you get this prefix happening before your working directory. So that's the activation command. I know, a little bit confusing. I hate that it's completely different on each operating system, but it just is what it is. Okay, so now we're inside of the virtual environment. So what we can do is type pip install -r and then use our requirements.txt file. So if we hit enter here, this should install all of the requirements for us inside of the virtual environment, and then we can test out our API using Uvicorn. Okay, so now that we have this working, we can use this Uvicorn command. So you can type it in and see if it works. It should give you some kind of result like this. If that doesn't work, you can try Python -m and then Uvicorn. Either way, Uvicorn should work. And then what you can do is start running the API. So you could say Uvicorn main :app, and then --host, go 0.0.0.0, which just means run on the public IP address of my current computer. And then you can say port 8000. Okay, this is the command to actually run your FastAPI API. When you do that, it should spin this up for you. I'm just going to allow this access to my network, and it will say that the database is connected, assuming that everything is working. To quit out of this, you can hit Control-C, and then you will close. Okay, so that's the command. If we quickly look at the command here, this works because the name of our file is main. So you need to make sure you name it main or change the name accordingly. And the name of our app is app, okay? So we're saying reference the main file and reference the app, which is our FastAPI application. That's why this is working. And then obviously the host and the port, you can change that to whatever you want. Okay, so now that we've got all of that, what we want to do is we want to move this code to our production environment or to our Linode. All right, so what I'm going to do here is I'm going to copy the contents of this folder, so web scraper API, to my remote machine in the home directory of my FastAPI user. Now, in order to do that, I'm going to use a command called scp, but before I can use that command, I just want to remove this virtual environment and this Pi cache so that I'm not copying over files that I don't need. I also don't need the database, but I can copy that over if I want. So what I want to do, first of all, is deactivate my virtual environment. Now, I could run the deactivation command, or I can just make a new instance of the terminal. And now you see that I'm no longer in the virtual environment. So that's good. And I also just closed out of the other one. So now I'm going to say rm-r venv, and I'm going to remove that virtual environment. I'm also going to remove the PyCache directory because we don't need that. So now we kind of have a clean directory. We can remove the database, but we also can move that over. It doesn't matter if we have that there. And actually, let's remove it just to make sure we don't get any issues with file permissions, for example. So let's do rm and then scrape jobs.db and remove that as well. Okay, so all of that's removed. We have just the 4 main files that we started with, and now we're going to use the scp command. Scp works like this. You can say scp, what you want to move, and then where you want to move it. But in order for this to work more effectively, we're going to change directories into the containing directory of the one where our code is. So what I mean by that is we have Web Scraper API. Well, that folder is on the desktop. So I'm going to move to the desktop so that I can reference this folder directly. Okay, so I'm going to say scp Web Scraper API, and then I'm going to define the location that I want to move this to. Now the location is on a remote server, so I'm going to say FastAPI at, and then I need to find the URL of my server or the IP address. So let's copy that here and paste it here. And then I'm going to say :/home/FastAPI and then /. Now this is the location I want to move it to. So I'm logging in to this server as FastAPI. And then I'm putting after the colon, the location on the server I want this folder to be copied to. Now I want it to be inside of home/FastAPI, which is my user. So that's why I'm putting this here. Now this will work as long as I put this -r, which stands for recursive mode, which allows us to move all of the contents inside of a folder. So let's hit enter here and let's type in our password. And this should start moving the files for us. So you can see the 4 files have been moved and now they should be on our server. So what we can do now is go back to our server, sign in, and now that we have all of the code there, we're ready to handle the deployment. So let's go back to our server. I'm just going to do it in a bit of a larger window so it's easier for you guys to see. And I'm going to SSH back into it like we did before. All right, so I just cleared the screen so we have a little bit more room here. You can see that I'm inside of my home directory, which is home/FastAPI. And if I type ls, you can see that we have Web Scraper API because we use the scp command. So now if I cd into Web Scraper API and I type ls, you can see that we have the files that we moved, main, models, requirements, and scrape.py. Amazing. Now we're going to create a virtual environment on our server. We're going to install the packages that we need, and we're going to start setting up the services in order for this API to be hosted persistently. So the first thing we'll do is we'll create a new virtual environment using Python. So to do that, we're going to say Python 3 -m venv and then venv. So we'll make that new virtual environment just like we did on our Windows machine or our local machine. And now we need to activate it. So since we're on Linux here, this will be the same command for everyone. So we're going to type source, and then this will be venv/bin/activate. When we do that, we'll see that we get the prefix with venv, and then we can install the packages that we need. So we'll simply go with pip install, and then this is -r requirements.txt. Keep in mind, all of these commands will be available from the link in the description with all of the resources, as well as all of the code for this project in case you're getting lost and you want to check that out. Okay, so this is going to take a second to download because it's not currently cached on our server. And then once this is finished, what we can do is, again, test the API and then move on from there. Okay, so now let's just quickly test the API. To test it here, we're going to do Python -m Uvicorn, and then we're going to go main:\app, and then --host, and then 0.0.0.0, and then --port. And then for the port, this is going to be 8000. Okay, so let's just test it, and you can see it says database connected. It connects, and then we can stop it with Control-C. Okay, amazing. So now that we've tested it, it's working, what we need to start doing is make this available publicly. So I can run this here, but it's only going to be available locally on my own kind of remote server, which is no good to us. What I want to do is actually use something known as a reverse proxy, so that when I run this command, I can actually route it to a public IP address of my server, so I can then access this API from anywhere as long as I have the authorization token. So to do that, we're going to start using something called nginx. So we're going to say sudo apt install, and then nginx, whatever you want to call it. Let's install that. It's going to require the password the first time we use the sudo command, which I believe I've already messed up. So I'm probably going to have to enter this again. Yep. Okay, that's what happens when I do too complex of a password. And when it asks for yes or no, we're going to go with yes and install nginx. All right, so nginx is installed. And now what we're going to do is edit the default configuration to allow our site to be routed. Now, nginx is something called a reverse proxy. What that means is that we can proxy or kind of route requests from a public IP address port to a local IP address or kind of a local application running on our own computer. So what I'm going to do is edit the following file. I'm going to say sudo nano, and then this is going to be /etc/nginx/sites-available and then /default. Now there's many different ways to set up nginx, but this is the easiest, so I recommend just use this. Okay, inside of here, you're going to be able to scroll down and see this default server configuration. Now what we're going to do is simply just delete it to make our life easier and then insert a new one. So Nano is the text editor I'm using here. A little bit difficult if you're not familiar with Linux, but I'll kind of name the commands out here so you can type them in. So what you're going to have to do here is hit Control-Shift-6, which is the hat. So you just need to access the hat. Again, it kind of looks like a hat. It's typically above the 6 key. And what that's going to do is set a mark inside of your file so you can start selecting content. So I did that right at this first line, right? I went to the server, like I put my cursor before server, I did Control-Shift-6. Then you can use the arrow keys to navigate downwards and just keep going until you see the ending brace, which is right here. Okay, so once you see the ending brace, then we can cut this out with Control-K. You can actually see it on the bottom of the screen. So I'm going to hit Control-K and I'm going to remove that default configuration. Now, what we can do is type in the new configuration or we can copy it. I'm just going to type it in to make sure that we get everything correct. But you can also copy this in. All of the configuration and all of this stuff I'm typing here, again, is available from the link in the description in the GitHub. But it should look like this. We're going to have server. Okay, again, because we're modifying the default configuration, we're going to be listening on port 80. The indentation doesn't matter, but I'm using tab here to indent. Okay, so we're listening on port 80. And then below this, we're going to say location and then slash. Now this means when you go to port 80 and you go to the slash, here is where we're going to route your request. So then inside of here, I'm going to put another set of braces. I'm going to tab this in. I'm going to tab inside of location twice. And we're going to say proxy_pass. And we're going to pass http://127.0.0.1 port 8000. Now, this is where our FastAPI application is running locally on this server. Then we're going to add a semicolon. So we're saying when you go to port 80 and you go to the base route slash, we're going to take that request and we're going to forward it over to this location. Now, there's a few other things we need to do. We're going to say proxy_set_header, and we're simply going to say host and then $ and then host, making sure that we preserve the headers. Then we're going to say proxy_set_header, and we're going to say x-real-ip, and this is going to be $remote_address. You don't have to worry too much about these lines, but they're required in order to make this work properly. Okay, then we're going to say proxy_set_header, and we're going to say x_forwarded like this. Make sure you spell this correctly. That's why I'm just quickly double checking. And we're going to say dash and then with a capital 4, and this is going to be a $, and then proxy_add_x_forwarded_4, and then a semicolon. Then we're going to go proxy_set_header, and then x-forwarded, okay, dash, and then proto, and then this is going to be a $, and then scheme. Okay, again, don't stress yourself with these lines. We just need it to make sure the configuration works properly. So that's it. We've just overridden the default configuration here, and we're now enabling this remote proxy to link to our FastAPI application. So actually, if we save this by hitting Control-S and then exit by hitting Control-X, now if we were to run our FastAPI application, we would actually be able to access this from any location by using the public IP address of this server. However, we want to make this a bit more robust so that this FastAPI application runs as a default service, meaning when we, for example, restart our Linode, it will automatically get started for us. And if we close our terminal, it's not going to stop running. So I'm just going to show you the more robust way to do this by using something called systemctl and something called supervisor. So we're going to type sudo systemctl and then restart and then nginx. Now this is going to restart the configuration. It's going to load this new default configuration for us. And it gave me an issue here saying failed because the control process exited with an error code. Okay, let me see what the problem is here. All right, so because of that mistake, I just went back into this file, and of course, I've made a few mistakes. So let's just quickly fix those. If you do get an error, don't freak out. Just make sure the file looks exactly as I have here, as I'm about to fix. And obviously, you can just copy in the finished, completed, tested code from the GitHub in case you're not able to get it from the video. So what I'm going to do first of all is I'm just going to go and make sure I spell forwarded correctly, because I think in every place I spelled it wrong. So that's pretty embarrassing, but that happens. So we're going to fix forwarded, because if you have any spelling mistake, well, it's going to give you an error. And then we're going to go to where it says listen, and we're going to remove the colon, because there should be no colon. It should just say listen 80. Now, I'm pretty sure that everything else I spelled correctly, but I guess we're not going to know until we run this again. So let's save it with Control S, exit with Control X. Let me clear and let me restart Nginx here. Okay, like we did before. And now this time it works because we didn't have any mistakes. Okay. So now Nginx is restarted, and as I mentioned, if we were to run the FastAPI application, it would actually work, and it would be routing to the public IP, so we'd be able to utilize it. However, what I want to do is start installing some software we're going to use to automatically handle running this for us, so we don't need to manually run our, FastAPI application. So what I'm going to do is type sudo apt install, and we're going to install supervisor. Now, supervisor is what it says. It's going to supervise different applications. So we're going to install supervisor, wait for that to finish, and then set it up. Okay, so now that supervisor has been installed, I just cleared the screen, and we're going to make a new file. Now, to do that, we're going to type sudo nano / and this is going to be etc / supervisor, if we can spell that correctly, /conf.d, and then /fastapi.conf. Now, all of the code I'm about to put here is available from the link in the description, so feel free to copy it in, and that's what I'm going to do here. So this is what we have. We have program : FastAPI, and then there's two things that we need to change. Now, where it says path and then venv, we need to put the path to our application. So that's going to be /home /FastAPI, which is the name of our user, / and then this is going to be web scraper -API. Okay. And then same thing where it says path to our app, we're going to say /home /FastAPI /web scraper -API, and then a /. And then make sure the user is equal to your user of FastAPI, or whatever you call it, but mine's called FastAPI. Okay, now I'm going to save this with Control S and then exit with Control X. And this should be all we need. And we're going to run this configuration file just continuously, and that's going to run our FastAPI application. So now that we've done that, what we can do is type sudo and then supervisorctl and then reread. So it should find that configuration. Then we are going to type update. So sudo supervisorctl update, and then we're going to start the service. So start and then FastAPI. Okay, so that should start it for us. It should say FastAPI started, and then our API should actually be running, and we should be good to go. So if we want to test our API out, what we can do is go to our browser, and we can type http:// and then paste the URL of our server. So I've got it right here. This, again, I just got from my Akamai Cloud Manager, and then I hit enter. And if we get something popping up here, even if it's an error message, that means that the API is running. If I try to go to something like /status/1, it should say, hey, we're missing, for example, the authorization header, which we are, but you can see that this is working. Now I'll show you quickly how we view the logs on here in case you are getting some kind of errors, and then how we can actually send a real request using Postman. So to view the logs, you can do cat /var /log, and then there's two logs, one for errors and one for general logging. Now it's going to be FastAPI.log. That's going to give you the general logs, so you can see kind of what's happening here with the database connection, etc. Then if I clear out of this, we can go to the error logs, so .error.log, and it will have any errors and then kind of the running of the application. Okay, so let me clear, but that's how you view the logs. And that's it. Now we can close this. We don't have anything more we need to do on our server, and we can start testing the API using Postman. So I'm going to use Postman. If you don't already have this, you can install it for free. So if you just go Postman, download like this, and you find it, you can just download for your operating system. Very easy, very fast, easy to use. Okay, download that. Now we're going to go to Postman. I'm going to paste in the URL of my server, make sure I have HTTP, and I'm going to try to send a request to start web scraping. So I'm going to go to post, I'm going to go to /submit, and then colon. You can see I was testing this previously. I'm going to go URL is equal to https://techwithtim.net. So I'm going to use my website here. And then what I need to do is go to authorization, and I need to add a header. So I'm going to go authorization, API key. I need to make sure this is called the XAuth token. And then I need to put the value that I had on my server. So in this case, it was my secret API token, but you probably used something more secure. At least I hope you did. So you can paste that here. Okay, now we can test this post request by pressing send, and we should see that we get something. For example, we have job ID 2, status submitted, because I was testing this previously. Okay, so now if I want to find the status of this, let's make a new request in Postman. Let's change it to this URL, or use the same URL as before. Let's go /status/2, because that's the ID. Go to authorization and add our API key, and then press send. And you can see that we get job ID 2, status complete, and then the title of the website is this, Tech with Tim, your ultimate resource for learning to code. So the API is working, we've tested it with Postman, and now you have a fully deployed scalable API using an Akamai or /Linode server, whatever you prefer to call it. And that pretty much wraps up this video. So there you have it. That is the project. I hope you guys found some value from this and were able to get a solid base that you can extend and make your own. Again, if you are looking for great virtual private servers, make sure you check out Akamai and use that link below for $100 in free credit.